Hello and welcome to my series Learn Radiology with Dr. Anil Joshi. Today's topic is based on the radio physics and that is also a simplified form. Today we are going to see how a step up and step down transformer works. Now transformer are of three types: step up, step down and auto transformer. Auto transformer is covered somewhere else. In this lecture we are going to see only step up and step down transformers. Now to start with a disclaimer. Most of the material we are using here is our own from our routine departmental teaching files. But some may be downloaded from the net, but we have confirmed it is a royalty free and there are no restriction as far as using for teaching and learning purposes are concerned. We acknowledge with thanks those from whom we have got this material. Now let's come to the topic, that is the transformers. A transformer is a device that either increases or decreases voltage in a circuit. It is understood that voltage and current are interlinked. So when we are changing one, other is bound to be changing. Now, this we use when we want a potential difference, that is the voltage different from that is the incoming voltage. So when incoming voltage either is increased or decreased, for that purpose transformers are used. Now step up and step down transformers are names when the voltage is increased, that is step up, and when the voltage is decreased, that is a step down transformer as compared to the incoming line. Now auto transformers are discussed separately and their applications are also different. Today's topic is step up and step down transformer. Alternating current, AC current, is used for a transformer as it is produced by a potential difference that changes continuously in magnitude and polarity in each cycle. So if you observe the cycle, you can see in that there is a one upstroke and second is downstroke, which indicate there is change in potential difference. So also polarity. Now, so an alternate current in primary coil is in a transformer produces alternate current in the secondary coil. Now, as per the requirement, there is a fixed primary which gives around 220 to 240 or 440 volts. From that, we increase the output to the desired potential difference. When current flows through the primary coil, it creates a magnetic field within the core, and this field induces a current in the secondary coil. Current only flows when the magnetic field is changing, either increasing or decreasing. For this reason, a steady like direct current DC from battery in the primary coil cannot be used to produce a continuous current through the secondary coil. Here we have shown a basic principle of transformer. What it has got? It has got a primary which is shown here as AC incoming. Then there is a core, that is iron core, and then there is a primary which is shown as a out, AC in, AC out. Now here you are seeing that the windings are different. AC in the primary or windings in the primary and windings in the secondary decide what is going to be output. Now what is the transformer theory? Transformer do not work with direct or unchanging current, that is DC current. Current induced in secondary coil only when primary current or magnetic field is changing. You are seeing here, if you put DC as the incoming, there will not be any output because there is no change in potential difference. DC is a continuous wave. So here you are seeing that if you try to design a transformer, will not be designed, it will not be work with a DC current. We are continuing with the transformer theory. Then transformers after both voltage and current of AC waveforms. Voltage in secondary can be more or less than the voltage in the primary. So depend on that, your requirement. The secondary will have voltage either more or less than that of the primary. Here we are showing input, there are more, winding is more than the output, so this will be a step down transformer. Now there is a turn ratio which governs the transformer theory. The number of windings of the secondary coil divided by number of windings of the primary coil. This gives you a diagrammatical presentation of the turn ratio definition. The law of transformer. Simple law governs the behavior of a transformer. The voltage in the two circuits is proportional to the number of turns in each two coils, that is primary and secondary. This is a law. Coils in the secondary, coils in the primary, and voltage in the primary and voltage in the secondary will be decided by this transformer law. To make it in more diagrammatical way, and a small quiz for you to solve by pausing the video show. The current changes opposite of the voltage changes. If one goes up, the another has to go down. If secondary voltage and primary voltage are governed, which is more or which is less, and that will give us a current in primary or secondary. So this is a simple formula which you can easily remember for step up or step down transformers. Now coil design, as it is said, is extremely important in transformer designs. How the coil is designed? It consists of two core wire wrapped around a closed core. The circuit containing the first coil connected to the available electric energy is called as a primary circuit. So a circuit which is connected to primary or which is connected to the supply available is called as a primary. This has got a fix that of the incoming voltage, either 220 or 440 in our region. The circuit containing second coil from which comes modified electric energy is called as a secondary coil. Coil usually wrapped around a core material such as steel. This improves magnetic coupling between the coils. Core is shown by the red lines. Now incoming AC power, you are seeing a primary coil, then is a core, and then there is a secondary. So primary is the one to which you apply a electric supply, and secondary is one which gives you a desired output. The secondary coil can have either one set, more than one set. We are seeing in X-set transformer, a same transformer can be used for the output of two different circuits, because what we do here, a primary is same and there are two sets of secondary in the secondary coils. So that gives you two different as per the windings. The primary coil induces voltage in both the secondaries. That's why, see here how it works. A primary is one, but there are two secondary coils. Similarly, you can have two or more coils, or you can have one coil also. Now coil design, we are continuing. When secondary coil field changing, that increasing or decreasing magnetic field of the primary, a power is induced in a secondary coil, or electric supply will be produced in a secondary coil, even though there is no physical connections, as it is shown here. The coils are totally different. There is no physical connection between these two. Now what are the types of transformers? Whenever an electric current flows through a conductor, magnetic field surrounds that conductor. Now magnetic field can be connected by coiling conductors. So that can concentrate. You can concentrate magnetic field by coiling conductors. Here it is shown. Now this is the calculation by which you can calculate the primary coil secondary coil ratio, and that will give us either increase in potential difference or decrease. But one thing is very sure, when the voltage increases, the current drops. So kV increase, MA will be less. Now we are at the summary. summary of types of transformer. We have got auto transformer, which we discussed somewhere else. We got step up and step down transformers. Here we have shown you diagrammatically step up transformer, step down transformer, how a primary and secondary, the ratios can change output voltage. So let's summarize everything. A step-up transformer increases the voltage and decreases the current, while a step-down transformer decreases the voltage and increases the current. This law assures or assumes that 100% transfer of the energy which cannot be achieved. So what happens to remaining energy? It gets into the heat energy. So that heat needs to be dissipated or removed from the transformer. The designing of core or embedding into the coil, into the oil is for this to dissipate the heat production. With that, we are coming to a brief lecture over the transformer, mainly step up and step down transformer. I thank you for giving me your valuable time. Please visit our website or YouTube channel. Gather more and more information. There are a lot of lectures, lot of topics, different varieties of cases discussed there. So do visit the website, make best use of it to increase your knowledge. Thank you, goodbye, and good luck. Take care.